Okay, last time I'm gonna ask. Willie, put those away.
Sorry, I just have to send one quick text.
Okay, make it quick. All right, so let's see here. I want to go through a couple quick examples from 6.7. 6.7. I think this will come back to you. I think once we start talking about it, you're going to say, "Oh yeah, okay, I'm remembering this." But it's been a little bit, so let's talk about it. There's two parts to this. The first part is the one where you're using what's called the factor theorem. I don't care if you know it's called the factor theorem. Completely unimportant to me. All I care about is that you understand the strategy you're going to use to solve this. So if we're given a function up here, f of x, right, and we're given a0 of this function. Now this is a cubic function, right? So it's a third degree. Everybody agree? Third degree polynomial. That's the biggest power of x. So how many complex zeros are there going to be, including i's? How many complex zeros are we guaranteed to get for a third degree polynomial? 3, guaranteed, right? Now it's possible that one of them could be a double root where it's like, like if we had, you might get the same answer more than once. And next year you'll talk about that in terms of multiplicities. I mentioned it this year, but you'll do more with that next year. But you have to get 3 total, right? One of them is given to you. So your job is to find the other 2. Now for this problem, it's only asking for the real zeros. So if they're imaginary, you would, I'd cut off the rest of the instructions, but it would say just enter NA or something, right? There are some other questions where you have to get all the complex ones. So if it's imaginary, I want it, including the i's. It doesn't really make any difference. Either way, it's the same process. So what do? Well, if this is one of the zeros, then we could take this function, f of x, which is 4x cubed minus 9x squared minus 51x minus 20, and it's got to equal a product of some factors. Well, one of the factors is going to come from that information. If 5 is a 0 of the function, that means if I plug in 5, I'm getting back 0 for an answer. Remember that if you have a 0 of the function, that always goes with a factor, right? And here's the formula for that. If k, the number k, is a 0, then x minus k is a factor. Guaranteed, right? So then this tells us that x minus 5 is a factor of 4x cubed minus 9x squared, blah, 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 f of x, right? Our goal is to find what the other one is, so that when we set this whole thing equal to 0, we can set the other factor equal to 0 to find the other zeros of f of x, right? One of them we already know. If I set this equal to 0, what am I going to get? 5, right? That's already given to us, right? That one we know. There it is, right? But we got to find the other one. So what would we do to find this other factor? Right? If we wanted to find this other factor, wouldn't I just divide both sides of this equation by x minus 5? Everybody agree? Like, I don't know what this is called. I don't know what this is equal to. But for now, let's just call this thing q, right? Whatever, we'll solve for q. So if I divide both sides of this equation, and I'm just going to cheat here a little bit. I'm just going to do this. Okay, so if I want to find out what q is, like we just said, we're going to divide each side of this thing through by x minus 5, right? That's just that's a division problem that I can do using synthetic division, right?
Yeah.
Okay, so using synthetic division, wouldn't this whole thing just look like inside the brackets, my coefficients would be what?
4, -9, -51.
And then out front,
Negative.
no, 5. Right? Which we could also get from right there, right? And so our goal then is we just need to figure out, now I know what has to go in the box.
0.
Has to be 0, right? Because we're told up here that f of 5 is equal to 0, right? So we know right away that this has to be 0. Our goal is just to figure out what goes here, right? So we'll do synthetic division. What's that process again?
Bring down the 4.
Good, we bring down the 4,
By 5.
multiply by 5 and get 20. What's all that nonsense? There we go. Wow. Look, that's, isn't that weird? How did it do that?
You broke it.
Sometimes this thing is a little goofy. Right, so we bring down the 4, we multiply by 5, and we add, and what do we get?
Negative or 11.
11 times 5,
55.
we add,
4,
times 5,
0.
and we add those, and sure enough, we get our 0. Where'd the 0 go? Oh, I guess I erased that, didn't I? So we get our 0 that we knew we were supposed to get there, right? So then this tells us right here what Q is. So what is it?
4x squared plus 11x plus.
There you go. Okay, good, because that's really just A, B, and C, isn't it? If this is quadratic, that's the constant, coefficient of x squared. So we're just solving the equation 4x squared plus 11x plus 4 equals 0. So if we wanted to write it, we know from here that this is just telling us, that what goes in there is, what was it again?
4x squared.
4x squared
11x
plus 4. Okay? That's what goes in there, right? Because we divided it out synthetically, right? So then, how do we solve this equation if we set this equal to 0? How are we going to solve that?
Add 4.
Now, just think strategically. If I've got what kind of equation is that?
You can do the quadratic.
Yeah, it's a quadratic equation in standard form, isn't it? Ax squared plus bx plus c equals 0, right? And if a is not equal to 1, we don't want to try to factor this thing. Right? We're just going to use the quadratic formula. We'd only factor this if it's really easy to do, where magic numbers are obvious, right? So then we would just say, we're going to use the quadratic formula, and we're going to get x equals negative b plus or minus the square root of b squared, which would be 121, right? Minus 4 times a times c, all over 2 times a. 2 times 4 would be 8. And so if we simplified all that, what would we get? Negative 11 plus or minus the square root of 121 minus 64 would be 59. Oh, no, that's not right. 64. Yeah, 57, right?
You say 59?
I think it's 57. 64. Yeah, 57. All over 8. You could do that in your calculator, though. So those are my other two solutions, right? So if I wanted to put all these into Moodle, then what would they look like? Now notice it tells me to include all of them, even the one that's given to me, right? So in Moodle, I would have to include the 5, comma. Then I would do negative 11 plus the square root of 57 all over 8, comma, negative 11 minus the square root of 57 all over 8, right? Those would be my 3. There's a lot of stuff we went through here, but in doing a problem like this, we can be pretty efficient, right? We just know that if this is one of the zeros, to find the other zeros, I could have just jumped right into the synthetic division part. I could have jumped right to there, because that's the 0 So I know a 0 goes in the box. Those are the coefficients. When I divide this through synthetically, that's what I'm left with. And so that's the polynomial I'm setting equal to 0 to find the other zeros, right? Okay, and that's, so we didn't really have to, I just kind of reviewed the whole theory behind this, but when you're doing these problems, you can be pretty quick about it. Okay, let's do another one that's just like this. This is actually a quicker one. Now I want you to think about the context though. It says find all points of intersection of the two curves. So the two curves are f of x and g of x, right? They're telling us one point of intersection occurs at x equals -5, right? How do we find where functions intersect?
Where they.
Well, okay, I mean, sure, but what would you do in Desmos?
You just type it in.
Type in the parent function.
Well, okay, but now you guys we're making this overly complicated. If I've just got some function f of x, and I want to know where this function crosses that function in Desmos, what would I do?
Plug in f of x equal to each other.
I would, probably what I would do is plug it, type in this one and type in that one and see where they intersect. You're right.
And then,
Okay, so I guess Desmos may not be the best way to think about this.
and then map
But if
it.
I wanted to find out where they cross algebraically, then all I would have to do is just set the two equations equal to each other and solve, right? Yeah, Desmos would do it pretty easily because it would show me the points of intersection graphically. We don't have that available right here. But it's not hard to do. All I would do is set f of x equal to g of x and solve the equation that we get from that. That's our way of asking the math gods where they intersect, is by setting them equal to each other and they answer us with algebra. We got to do the algebra and find the answers, right? So if we do that, if we take this function, so f of x, x cubed plus 3x squared minus 11x plus 15 equals g of x. How am I going to solve that equation? What do I always do when I solve polynomial equations?
Move everything to the left.
Okay, good. Combine like terms, get it equal to 0. Put it in standard form. So we would just subtract x squared. We would subtract 2x. And we would subtract 5. Right? And then that's going to give us, over here, everything cancels and I get my 0, right? Over here, I get x cubed plus 2x squared minus 13x
Plus 10.
plus 10 equals 0, right? Are you guys getting this over here? Okay, you're going to need to. So now, that's the equation I'm trying to solve. Do I know a solution?
Yeah, -5.
-5, right? It tells me that x equals -5 is one of the places where this all happens, right? So that's one solution. That's a 0 of this function right here, isn't it? Everybody agree? Okay, so how could I do this really quickly then?
We'll do the -5.
Yeah, I mean -5 is going to be the 0 that I'm going to synthetically divide into this function right here. Everybody agree? Okay? So let's do that. So here's the coefficients are just going to be what? 1, 2, -10, and out front I'm putting -5. And what has to go, we know already.
0.
Yeah, we have to get 0 there, don't we? Right? Because it tells us that we do, right? That's a solution. So then all we need to do is synthetically figure out what the other stuff is we get. I get 1.
5. -5.
So what's that give me here?
-3.
-3 times -5 is 15.
So 2.
2 times -5.
0.
So we get our 0. So those are the coefficients. Question?
Oh, no.
Okay, so those are the coefficients of the other factor that we're going to set equal to 0, right? So really what this is telling me is 1x squared minus 3x plus 2 is what I'm setting equal to 0. Okay? Okay, that one is easy to do.
No.
Magic numbers exist there, right?
Yes.
-2 and
-2 and -1. Very good. So my other solutions are at
2 and 1.
x equals 2, and x equals 1. Now notice, I messed this up earlier today. I didn't really finish this. I didn't read the question carefully. They want the points of intersection. So they want ordered pairs, right? So what do I have to do to find the points of intersection? If I know an x value, what do I do to find the y
Plug
value?
it in.
Plug it into either one of those, right? Because we're finding the places where the x and y values are the same for both functions. So why not pick the easy one?
G.
Agreed?
Yeah.
Use g. So then if I want to write down all my ordered pairs, I'm going to get -5, and if I plug -5 in, what do I get? 25 minus 10 would be 15 plus 5 is 20. So -5, 20. What were the other ones? I already forgot. 2 and 1.
Yeah.
So if I plug in 2, I'm going to get 4 plus 4 is 8 plus 5 is 13. If I plug in 1, I'm going to get 1 plus 2 is 3 plus 5 is 8. Right? So those are my 3 points. Okay? Okay, last one. This is the one that we probably need to go through the most. Okay, what this is saying here now, this is the same kind of problem, only this time the big difference is it's harder because we're not given a 0. We've got to find the first 0 on our own. Once we find the first 0, we can synthetically divide it through and get the other ones easily, right? But we got to find the first one. So here's the way we do that. It's called the rational root theorem. And there are notes on the site about this, but I want to remind you how this works. The rational root theorem says that if we have rational, meaning they can be written as fractions, we have rational zeros of a function, they have to be built from a combination of the factors of the constant and the factors of the leading coefficient, right? And the way that you build these things, they would have to be fractions where the factors of the constant go in the numerator and the factors of the leading coefficient go in the denominator, right? Okay, so what are all the factors of 9?
3.
Well, let's start with the easiest. So I get plus or minus 1. Those both divide in evenly.
Plus or minus 3.
Plus or minus 3 or plus or minus
9.
9. That's it, right? So the top of the fraction would have to include either plus or minus 1, plus or minus 3, or plus or minus 9. What about the bottom of the fraction, the denominator?
Plus or minus 1, plus or minus 2, plus or minus 4.
Right? So we're just going to make a list of all the possible fractions we can build by dividing the blue numbers by the red numbers. Okay? So here's our list. We're going to get, if I divide through, let's first do the easy one. If I divide through by plus or minus 1, I'm not really changing those at all, am I? Right? Dividing by 1 makes a fraction that has a 1 on the bottom, and so it's just an integer, right? So I would immediately get plus or minus 1, so I'd get 1, -1. Those don't show up very well, do they? Let's pick a different color. So what if we do, I'll make these green. So if we divide by plus or minus 1, we're just going to get 1, -1, 3, -3, 9, -9, right? What if I divide through by these, plus or minus 2? Well, then I'm just going to get halves on, I'm going to get 2 on the bottom of all those, right? So I would get, I'm just going to put plus or minus here. Plus or minus 1/2, plus or minus 3/2, plus or minus 9/2. Last one, what if I divide through by 4s? Well, I'd get either plus or minus 1/4, plus or minus 3/4, or plus or minus 9/4. Now here's the good news. You might remember I told you that for this year, I'm never going to give you any where you have to go as far as getting a fraction. In the future, you'll do that, but not this year. Right? This year, your answers will always be integer ones, which you'd find anyway, even if I hadn't told you that, because the strategy you want to use is start with the easy ones and eliminate those first before you do all the hard work to do the harder ones, right? So we'll just go to this list and try them until we get one that works, and we just have to keep checking them off the list until we find one that works. So let's start off with 1, right? If I pick a 1, and I plug it in synthetically, how do I know if it works? What's going to show up in here? A 0, yeah. So we'll try this. If I bring the 4 down, 1 times 4 is 4. 4 plus 22 is 26. Do you see a trend already here? They're just going to keep getting bigger and bigger, aren't they? It's never going to go away. So I could cross 1 off of the list and start over, right? And this, I mean, you can see that this potentially could take a while, right? It won't, though.
I don't think we do that.
So what if we try -1?
It's just gonna be the same thing but negative.
No, no, no. Because negative times negative is positive, right? So if I, now watch this one. So if I bring the 4 down, I'm going to get a 4 times -1 is -4. What's that give me?
Isn't that still
18?
18 times -1. Add those, what do I get?
Not 9.
Oh, that didn't work. Thought that one was going to work. I guess not.
Wrong.
Should I write? Huh. 18, I guess it didn't work. Okay, so that one we can cross off too. Okay, whoops. My mistake. Okay, that one didn't work. What about 3? We don't want to try 3 because 3 is just going to keep getting bigger and bigger and more positive, right?
-3.
Okay, let's try -3. That's got to be the one that works. Okay, so if we try -3, bring down the 4, 4 times -3,
-12.
what do those add to?
10.
10, yeah. 10 times -3,
-30.
that's going to work, isn't it?
Yeah, 3.
3 times -3 is -9, so they add to 0. And so all I've got to do then, that's easy now, right? I know A is 4, B is 10, C is 3, right? So this is, we're trying to find the zeros of 4x squared plus 10x plus 3. How am I going to do that? Am I going to try to, what am I going to do? Quadratic formula. I don't even need to write it down. It's giving me the values of A, B, and C. Plug them in, right? All I got to do here then is just x equals -b plus or minus square root b squared
Minus 4ac.
4ac. So what is that? 4 times 12 is 48. All divided by 2 times a. Do that right?
52.
Yeah, that's right. So I end up with -10 plus or minus the square root of 52. 52 is just 4 times 13. Right?
Yeah.
And then I could just break this into parts. I could break this into -10/8 plus or minus 2 radical 13 over 8, and I could simplify both of those. So 10 over 8 is 5 over 4, plus or minus 2 over 8 would reduce to 1 over 4, right? So plus or minus square root of 13 over 4, right? I mean, I don't even, you guys can do that part. That's no big deal, right? The main part here that I wanted to refresh your memory about was that, you know, how do you get this list of numbers that you have to just go through and check off? You know, the way you do that is that rational root theorem. Factors of the constant divided by factors of the leading coefficient, right? Okay, does that make sense? Okay, this is recorded. I'll update all this stuff so it's all in there for you, that you have access to it. You can have the rest of the period, not a ton, but you can have the rest of the period to work. Okay.